Hi students, this is Mr. Sia once again, and in this video lesson you are going to review how to find or determine the maximum and minimum value of a function on a given interval. This is something that you saw in Algebra 1. I know this was a couple of years ago, but I think you'll be able to do well on this assignment. Also, I'm going to give you a review on how to determine domain and range of a given function in interval notation. Okay, so follow me along on this lesson. Okay, so I'm going to ask you to add these two definitions, okay, or information on top of your notes. And I know I wrote small because I don't have a lot of space to write on, okay? So pause the video and copy what I wrote here. All right, so a minimum value, okay, so I'm going to highlight this one here, minimum, and then I'm also going to highlight maximum. And like I said in the introduction, you have seen this in Algebra 1. Okay, so a minimum value of a function on an interval is the smallest y value for the x values in the interval. Okay, and a maximum value of a function on an interval is the greatest y value for the x values in the interval. So let's go ahead and go into some examples so that this begins to make sense to all of you. Okay, so I have a few examples here. And so for example, I'm going to graph this line here, and then I'll explain how to find the max and min if you're given a graph. Okay, so I'm going to use rise over run for this one. So notice that we do have a y-intercept of 0 and -2, so the line crosses the y-axis at 0 and -2. So I'm going to plot that point first. So this is 0 and -2. X is 0 here, and y is -2. Now I see that this slope is a slope of 2. So there's an implied rise of 2 and a run of 1. So from this point, this has a positive slope. Okay, so I'm going to go up 1, 2, and run of 1. And again, 1, 2, and a run of 1. And I can get as many points as I want. 1, 2, and a run of 1. And I can also go down 1, 2, and a run of 1 to the left now. Once I have my points plotted, what I'm going to do is I'm going to use a straight edge here, a protractor, okay? So as long as you have a straight edge, you can use any type of straight edge. So on this, the purpose of this is you can draw straight lines, and sometimes I'm looking for information on graphs. And if you don't use a straight edge, your line might be crooked, and it's hard to tell if it's even the right graph for the equation given. Okay? All right. So once I've done that, I'm going to come to this interval that I'm given. Okay? Because I'm being asked to find the minimum and maximum values of each given relation on a given interval. So I'm given this interval from -1 to +3. Now, these are domain values, okay? So these are x values here. So I'm looking at where x is equal to -1, and x is equal to -1 here, and I'm going to draw a blue line here. And I'll explain why in a moment. And then I see that this is x is equal to 3 on this one, so it goes from -1 to +3. So then 1, 2, and 3, and I'm going to draw a line here. Now, why am I drawing a line? Because this is a closed circle. Okay, so I don't know if you guys remember this from interval and set notation. If it's a closed circle, that means it's being used. So this is using brackets. So that means -1 is being used for x, and +3 is also being used for x. So it's on the interval. Now, to use the graph to help you determine the maximum and minimum, all I have to do is that when x is -1, okay, so I'm going to just use function notation here, f of -1, this means when x is equal to -1, y is equal to -1, 2, 3, and 4. So -4. So this one here is going to be my minimum value on that interval. Okay, so this is my min. Now, what about the max? The max happens here when x is equal to 3. So f of 3, the value of y when x is 3 is 1, 2, 3, 4. So +4. So then my max is this value here. Okay, so this is what they're asking me to do. I'm going to review with you something else. So from previous 2 lessons, okay, what will be the domain of this function and what will be the range of this function? As you can see, and I'm only going to state this on interval notation. As you can see, it goes to this arrow means that it's not going to stop going to the left. So that means on the left, it goes on to negative infinity, but on the right, okay, this is going to continue going to the right. So it goes to positive infinity. Okay, that's the domain. What about the range? The range, same thing. This is going to continue going down and it's going to continue going up. Okay, so bottom, it goes down to negative infinity, and up, it's not going to stop going up, so this will be positive infinity. So there you have domain and range. Now, if I'm given a graph, and I need to find the x-intercept, okay, x-intercept, I'm going to use the graph, but if not, remember, we just had a lesson previous to this one on how to find the x and y intercepts. So I'm going to use the graph, and I see that the line crosses the x-axis here. So y is 0 and x is 1. So 1 comma 0, that's going to be the x-intercept. The y-intercept is going to be, okay, negative 2 and 0. So x is 0, y is negative 2. So this is what you can expect to see on the assignment. It's going to ask you for the maximum, minimum. It's going to ask you for the domain, the range. It's going to ask you for the x-intercept and y-intercept. Okay, so you're going to be asked to do a lot of information today for each one of the functions that you'll see on the assignment. So I want you to try this one on your own without graphing. Try to do it on your own and you'll see how this is done. I'm going to do the next 2 examples, and notice that on these 2 examples I don't have a graph. Okay, so what happens when you don't have a graph? Then in this case, this is what you do. Since I'm given an interval here, I'm going to use the values of x that I'm given. So wherever I see an x on this equation, I'm going to substitute that x with the negative 9 first. So I'm going to have, and I'm going to separate here so I have my space organized. Okay, this is just me. I like to keep my notes organized so that it's easy for you to follow. Okay, so let's start with f of negative 9. Okay, in one column, and that's going to be equal to 2/3, and in the parentheses instead of x is going to be a negative 9 plus 6. And on this one, I'm going to do the other value on the domain, which is 3. So f of 3 equals 2/3, and instead of x, I'm going to have a 3 now inside of this parenthesis. Okay, so instead of that x right there, and then I'm going to add 6. I'm going to start with this one here. So don't forget there's a 1 implied under that 9, okay? But before I do anything, notice that 3 goes into 9 3 times, and 3 goes into 3 3 times. So that means this 3 becomes a 1, and this negative 9 becomes a negative 3. And this 1 times 1 is going to be 1, and 2 times negative 3 is going to be negative 6. Okay, 1 times 1 is 1. So it's going to be negative 6 over 1. I'm not going to write it down. We know that it's still going to be negative 6. So plus 6. And in the end, negative 6 plus 6 is going to be 0. Okay. So then I'm going to bring this down here just to let you know that I'm still doing f of negative 9. And that's equal to 0. Now, the thing is, I don't know if this is going to be a maximum or minimum value. Okay. So keep that in mind. We'll come back to this once we're done with this one here. So let's do the same thing with this one here. So this is over 1. And again, I have 3 in the denominator of this one, and I have a 3 in the numerator. So these are going to simplify or reduce to 1. Okay? And then 2 times 1 is going to be what? 2 times 1 is 2. 2 over 1 is still 2. So then this is 2 plus 6. 2 plus 6 is 8. So that means when x is equal to 3, y is equal to 8. Now we can determine which is the max and which is the min. We see that this one is 0, so obviously this is going to be the minimum, and this is 8, so that this one is going to be the maximum. So the maximum value of y is 8 on the given interval, and the minimum value of y is 0, which is on the given interval. Okay, and I didn't do this here, so I just hope you understand what I just did. So let's go on to the next example, next and last example. Same thing here. I'm going to do f of negative 1. Okay, so f of -1 equals -2 times -1 minus 1/4. And then this one is going to be f of 2 equals -2 times 2 minus 1/4. Okay, so then this is -2 times -1, positive 2, minus 1/4. And as you know, again, you're going to keep coming back to fractions on this one. This is over 1. I need to have a 4. So that means I need to multiply numerator and denominator by 4. So when we do that, then this becomes 2 times 4 is 8. 1 times 4 is 4. And then minus 1/4. So now we have the same denominator. So then we just subtract 1 from 8. So 8 minus 1 is going to be 7. So this will be 7/4. So f of -1 is equal to 7/4. Again, we don't know if this is a maximum or minimum value. So let's go ahead and do this one and we'll find out if it is or not. So then this -2 times 2 is -4 minus 1/4. And again, we don't have a 4. We have a 1 under this 4. So we need to multiply top and bottom by 4. Okay, 4 over 4. So then once we multiply, this becomes -4 times 4 is -16, and 1 times 4 is 4, minus 1/4. Now we have a common denominator, so I'm just going to combine this 16 and this one, but this one is minus, so it will be -17/4. So then f of 2, okay, is equal to that. And again, I'm just going to bring this down because I don't want to copy the same thing over and over. And I'm going to do the same thing here. Okay, so then we know which is the max and which is the min. This is the smallest of the two. So this will be our minimum value. Okay, and this will be our maximum value on this given interval. I hope that makes sense. And if you have any questions, don't forget, you can always ask me through email, or if you're a face-to-face student, you can also ask me in the classroom. Okay? Thank you for watching. I'll talk to you on the next lesson. Bye-bye.